Alright, the objective for this lesson is that you'll be able to graph the reflection of an object on the coordinate plane. These notes were given on January 12th. This is Chapter 10-2, Part A and B. It's reflections and symmetry. Don't pay attention to my funky frog. Well, you can if you want. The frog's reflected across the y-axis. So here's some definitions. First one is the definition of reflection, and it's a transformation that flips a figure over a line. A transformation, in our last lesson, we did a different type of transformation. We did a translation. So a translation is a type of transformation. In this lesson, we're going to do a reflection, which is a different type of transformation. The next lesson, we're going to be doing a rotation, where you're going to move an object. And then we're going to do dilations, where we're going to change the size of an object. These are all different types of transformations. So here's a reflection of this triangle across the y-axis. So basically, like the definition says, this triangle is flipped over the y-axis. And the line that we're reflecting over is called the line of reflection. So in this case, the y-axis is our line of reflection. The triangle is flipped over the y-axis. Here's just two more examples of reflections. In this case, the first one here, the line of reflection is the x-axis. So we're flipping this pentagon over the x-axis. The next example, we're flipping this arrow over the y-axis. These are just examples of reflections. So we're going to start off with a very simple example of a reflection. Instead of an object or a shape, we're just going to reflect a point. So this says graph the point A, which is at 3, 2. So walk 3, climb 2. There's point A. Then graph its image after it's reflected over the x-axis. It's not difficult, but this is where I see the most problems in this lesson, is people not paying attention to what they're reflecting over. So you need to read carefully to see what it is you're reflecting over. In this case, I'm reflecting over the x-axis. So how do I reflect A over the x-axis? It's very simple. All I do is count how far away A is from the x-axis. It's 1, 2 units. I'm 2 units away from the x-axis. So when I flip this over, I should still be 2 units away on the other side. So I just count 1, 2. And this is my reflection of A, which I'm going to call A prime. So you're just looking to see how far away the point is from the line of reflection. Make it the same distance away on the other side. It's that simple. I'm going to skip that one. Graph the reflection of BCD after it's reflected over the y-axis. Again, the most important thing here is paying attention to what you're reflecting over. So it says reflect this over the y-axis. So hopefully you know this is the y-axis, the vertical axis. So I'm going to reflect this over the y-axis. So we just did an example where we reflected a point. Now we're going to reflect a shape. But keep in mind, the shape is really just made up of 3 points, B, C, and D. And they're connected by lines. So if I reflect each of these points over the y-axis and then reconnect the dots, it'll form the shape again. So let's look at this. Do the same thing as we did on the previous example. See how far away each point is from the line of reflection. So point B is 1, 2, 3, 4, 5, 6 units away. So I want to make it 6 units away on the other side. 1, 2, 3, 4, 5, 6. And now that's my new point B, which I'm going to call B prime. Do the same thing for point C and point D. Point C is 1, 2 units away. So 1, 2. That's my new point C. I call that C prime. You don't have to draw these lines here that I'm drawing. I was just drawing that to show you. You don't have to draw this line on the line of reflection. I'm just doing that so it's clear to you what exactly we're doing. Point D, my last point, is 1, 2, 3, 4 units away from the line of reflection. So make it 4 units away over here. 1, 2, 3, 4. That's D prime. And now all I have to do is reconnect the dots, and I will have the reflection of that triangle. So connect all of these dots together, and that's my reflection of BCD. So it's really very simple. You're just breaking the object into different points, seeing how far each of those points is away from the line of reflection, and making it the same distance away on the other side. Here's another example. This one, I actually didn't do this example in class, but I'll do it here for you. It's actually more complicated than you guys are required to understand, but it's the same rules apply. You do it the same way. So first of all, I'm reflecting this over the x-axis. So I'm just going to highlight that so that everyone is aware of which axis we're doing. So this is the x-axis. We're going to reflect the shape over this. So let's graph these points. Point E is at 4, 3. 1, 2, 3, 4. 1, 2, 3. That's point E. Point F is at 1, negative 4. And point G is at negative 1, 2. So the reason this one is more complicated than the other one is that 2 of the points are on this side of the line of reflection, and one of them's on this side. So let me connect these, and then I'll explain this a little further. We're going to do it the exact same way. You're actually going to end up with a pretty cool image when you're done. So think about this. Point G and point E are going to get flipped over to this side. G and E are going to get flipped over here. Point F is going to get flipped over to here. So you're still counting how far away you are from the line of reflection and flipping it over to the same other side, the same distance. So point G is 1, 2 units away, so 1, 2 on the other side. Point E is 1, 2, 3 away, so 1, 2, 3 on the other side. Point F is 1, 2, 3, 4 away, so now it's going to go 4 away to the other side. 1, 2, 3, 4. Again, labeling these, this is G prime, this is E prime, this is F prime. And so now we're going to connect those. Let me change the colors here so it stands out. All right, I'm going to reconnect the dots. And that's what you get. All the problems that I will give you for homework or on tests and quizzes, all the points will be on the same side of the line of reflection. So this is a little more complicated example, but you can see it's not really any harder. You're still just counting how far away you are, moving it the other side of the line of reflection the same distance away. All right, the next topic here is symmetry. So it says if a figure can be reflected over a line so that its image matches the original figure, the figure has reflectional symmetry. Here are some examples of figures with reflectional symmetry. So what I want you to get out of this is there are lots of things in the natural world that have reflectional symmetry. Think about this. Do you have reflectional symmetry? Is there a line that I could split you in half and the left side would be the same as the right side? Hopefully you're saying yes, there is. If I cut you right down the middle, the left side of you would be symmetrical with the right side of you. Hopefully. I'm sure there are people out there that's not true. Here's a butterfly. Here's my line of symmetry. The left side and the right side are symmetrical or the same. A leaf has reflectional symmetry. This flower has multiple lines of symmetry. If I was to cut the object on this line, the left side and the right side would be the same. If I was to cut it on this one, the left side and the right side would be the same. So what I want you to get out of that is that an object may have more than one line of symmetry. So let's move on to some shapes. It says determine whether the following shapes have reflectional symmetry, and if they do, then draw the lines of symmetry. And again, there may be more than one line of symmetry. So let's look at this trapezoid first. We got a trapezoid. If I put the line of symmetry across here, would the top and the bottom be the same? No. What about if I put the line like this? If I folded this in half over that, would it match up perfectly? The answer is no, it would not. All right, bear with me 1 second. Get rid of those. So, the line of symmetry for this trapezoid is straight down the middle. Let's see if I can scoot this over a little bit. Right there. That's the line of symmetry for this. The left side and the right side are equal. Look at this triangle and see if there's any way I can put a line that would make both sides symmetrical or the same. The answer is no. This shape does not have a line of symmetry. So this one is not symmetrical. I can't remember if there's two M's in symmetrical or not. That's why I teach math. Looks right. I don't know. If it's wrong, I'm sure you'll let me know about it. And the star. Look at that and see if you can come up with a line of symmetry on that. There's actually more than one line of symmetry on this. Here's one. Let me shift this over. Here's one line of symmetry. Look, the left side and the right side are the same. You see any other lines of symmetry? How about right here? This side and this side are the same. Another one right there. And another one. And one more. These are all lines of symmetry. So with any of these lines, both sides of the shape are symmetrical. If you cut it down that line, you'd have two equal symmetrical sides. Basically, the reason this lesson is tied in with reflections is, let's look at just this right now. If you look at the left side and the right side of this, they're reflections of each other. So that's really what line of symmetry is the two sides are reflections of each other. If you look at the distance of this point versus the distance of this point, they're the same different distance away from this line. Okay, so that's symmetry. There's no magic rule or anything to teach you symmetry. It's something you have to be able to observe, and with practice it's easier for you to see the lines of symmetry. And I guess that's it. So hopefully this was easier for you than translations. There's no rules to write. There's no math involved. It's all just about pictures. So if you need to review any of this, back it up and watch it again. So Mr. Bywater is